Hi students, so welcome to new topic size transformation. So without wasting time, we will start today's topic for a size transformation. It is a part of similarity chapter. So in 10th standard, uh, you require some basic concepts or the basic knowledge for this topic. And the basic knowledge would be very simple, kind of how to solve the equations and like kind of the metric systems, like how to convert units from one system to another system. So it's a very simple topic. So in case uh, you are not clear with the metric systems or some formulas of this topic, do not worry. I'm gonna make it today very clear to you all. So keep watching this video till the end so that you will understand the entire size transformation topic with formula, with conversions of metric unit, as well as few sums, and the most important thing, the basic concept of this chapter, size transformation. So let's begin. Be ready with notebook and pen so that as I'll go ahead with the video, you'll have to keep writing whatever the information I have put on the board in your notebook so that your notes will also be simultaneously prepared as it will go forward with this video. So keep ready your notebook and pen. I'll take a pause for a minute. Good. So all those people who are watching this video, you have one important instruction. So in case if you have doubts or difficulties or any questions which you're not following over here on the board, you can immediately type in that comment box, which I have over here, comment box open. So you will immediately answer with the doubts. So guys, all the best. Let's learn size transformation. So what is size transformation? Where exactly the size transformation is used and why this is important? Why we are learning this in 10th standard syllabus? All that questions you might have in your mind. So keep watching this video. I'll answer all these questions one by one. So what exactly is the size transformation, student? See, the size transformation is nothing but either you enlarge the image or the shape, or else you diminish the figure or you diminish the observations. Like where exactly we do this enlargement or the diminishing things, it's very simple. Say, suppose you take nowadays selfies in your camera, isn't it? So the selfies is nothing but diminishing your size into that camera size, isn't it? So you might be 5 feet tall or 4 feet tall or 6 feet tall or 8 feet tall. You completely come into your camera screen if you take a proper selfie, isn't it? So selfie is nothing but diminishing your size. Or else some another example, say you must have seen, say Taj Mahal on A4 size paper, isn't it? Do you think so? Taj Mahal can fit on A4 size paper, which is quite difficult, isn't it? But some people can click the Taj Mahal photo, and then that photo in two-dimensional you can see on A4 size paper, isn't it? So again, the Taj Mahal has been diminished. Or else, oh, what we are talking about the Taj Mahal, we can see the entire world on A4 size paper. Do you know where? On the map, perfect. On the map, we can see the entire world on A4 size paper. So that is size transformation. We converted the entire world on A4 size, isn't it? And how do we do that? By reducing the scale factor. Or this was all the examples of diminishing the size. So what are the examples of enlargement? Say, whatever screen is like right now, you must be watching my video probably on your mobile, or some people might be watching it on the TV screen, or some might be watching it on their tablets, or some might be watching it on their laptop or PC. So everyone have their own screens, but the video would be the same, isn't it? So the example was like we see a movie in theater. So in theaters we see that a huge screen, that is enlargement, isn't it? So that is where the size transformation come into the picture. Or else I'll give another example. Say generally before constructing the mega structures, they make the models of that mega structure. The models would be like too small compared to that mega structures. And why do they make that models? It's like very very useful things, because whatever the views you want, from which building you'll be standing, or from which directions you'll be standing, or what will be the exactly view of particular flats or particular balcony, you can come to know by just observing the models. Or else before constructing those huge ships or the big aeroplanes, they make models of those particular mega structures, and those models are very very useful, because all the measurements, all the areas or the surface areas or the volumes or the length or the breadth or the height, all are in proportion. So in this chapter we're going to see all that things one by one with few examples. So before starting the example, let's start with few concepts. So in case students, if you have some doubts or difficulties, don't worry, you can write it down immediately in the comment box till now. So let's go ahead with the size transformation. So I just spoke, something called as diminishing the size or enlarging the size. So see this, it's depend on the scale. So what is the scale? K is nothing but scale. So scale is denoted with some factor, constant K, which is 1 by 10 or 1 by 100 or 1 upon 10,000, or it can be anything in your topology or topography classes of geography. You must have learned this kind of case, isn't it? So anyway, how exactly this K is useful, we'll see one by one. See, this is K. K is 1 upon 100. What is this 1? 1 on map is equals to 1 unit on map is equals to 100 units on the ground. What it means? 1 unit on map is equals to 100 units on the ground. What it mean by that? Say, if you will take 1 centimeter on the map, which would be equivalent to 100 centimeter on the ground or on the actual length. Are you understanding? So if the breadth is 1 centimeter on the map of the river, that means it is 100 centimeter long on the ground. It's just an example. A river can't be 100 centimeter, isn't it? So just for an example, if it is 1 centimeter on the map, the length of the road is 1 centimeter on the map. That means 100 centimeter is on the ground. I hope you have understood. So this is basically one dimensional. Whenever it is K, it is one dimensional. One dimensional things are like length, breadth, height, diagonal, all these are. I'll make a note. What is one dimensional things? What is this one-dimensional things are? Length, breadth, height, and diagonals. So all these length, breadth, height, and diagonals are one-dimensional things. What are the two-dimensional things? Area, surface area, curved surface area, are all that are the two-dimensional things. And what is this three-dimensional thing would be? Volume. Very good. So what is the formula? First formula? Say, this is the first formula. Length on map is equals to k times length on the ground. I'll repeat. Length on map is equals to k times length on ground. I'll repeat once again. Length on map is equal to k times length on ground. So let's repeat along with me. Length on map is equals to k times length on ground. That's perfect. So please jot it down in your notebook. Okay, so in case if you have written down, let's go ahead. So the formula goes the same as length or breadth or the height or the diagonal. See, look at this. Length on map is equal to k times length on ground. So you can please complete this in your notebook. Breadth on map is equals to k times breadth on ground, or else height on map is equals to k times height on actual. This is diagonal. This D stand for diagonal. I have written over here diagonal. Diagonal on map is equals to k times when we come into two-dimensional, this k goes k square. It's so obvious. See, area on map. Now how the area become actually? Area is nothing but k times, and the breadth is also getting multiplied k times, so it will become in area, it will become k square. Just note down, it is k square. So area on map is equal to k square area on ground. Area on map is equals to k square area on ground. Let's repeat once again. Area on map is equals to k square area on ground. I hope you are understanding this. Let's repeat along with me once again. Area on map is equals to k square area on ground. Please jot it down in your notebook. So once you got the area, once again, the people who have just joined, keep your notebook and pen ready so that I'll give you some space to write it down, some notes. So you can write it down simultaneously. In case if you have doubts or difficulties, you can put in the comment box. Do not write that hi, hello, I am this, I am that in the comment box. Write your doubts and the difficulties in the comment box. So anyway, we'll go ahead. If it is area, it becomes k square. If it's one-dimensional thing, it is k. If it is two-dimensional thing, it is k square. What if it is three-dimensional? Like if it is volume. So what will become in the volume? Obviously, the volume of model is equals to k cube volume of actual. Volume of model is equals to k cube volume of actual. So what is the volume of model? Volume of model is equals to k cube volume of actual. Say, repeat along with me. Volume of model is equals to k cube volume of actual. Say once again. Volume of model is equals to k cube volume of actual. Please jot it down in your notebook. I hope this is all very clear till here. And now the next part of the chapter. The next part of the chapter is here we completed all the basic formula of the chapter. And now the next part of the chapter is the conversions or the metric system unit. So we'll see one by one. Look at this. What is this? 1 kilometer is equals to 1 kilometer is equals to 1000 meters. 1 kilometer is equals to 1000 meters and 1 lakh centimeters. So write it down in your notebook. 1 kilometer is equals to 1000 meters or 1 lakh centimeter. So the same thing can be written as in the new format, like 10 raised to power 3. See, this is 10 cube, isn't it? That's 10 raised to power 3 meters. This is 10 raised to power 5 centimeter. Now, what error generally people do make over here? Like, they write 1, 2, 3, 4, 5. And on 10 there are only 4 zeros, so they write 10 raised to power 4. Actually, that is wrong. It is 10 raised to the power, whatever the number of zeros. 10 raised to the power, whatever the numbers are number of zeros. So do not write 10 square as 1000. Are you understanding? So this is what generally people make an error. So this was one very important conversions in one dimension. 1 kilometer is equals to 10 raised to power 3 meters and 10 raised to power 5 centimeters. So vice versa, in case if you have to convert 1 meters to 1 kilometer, it will become 10 raised to power minus 3. And if it is 1 centimeter is equals to dash kilometers, 10 raised to power minus 5 kilometers. Very good. So the next thing is 1 kilometer square is equal to 10 raised to power 6 meters square. Now how exactly this has occurred? See, 1 kilometer square. What is 1 kilometer square? 1 kilometer into 1 kilometer. Now what is 1 kilometer? 10 raised to power 3 meters. And what is 1 kilometer? 10 raised to power 3 meters. So 10 raised to power 3 to 10 raised to power 10 raised to power 6 meter square. I hope you have understood that. Isn't it nice? Same thing, 10 raised to power 5 centimeter into 10 raised to power 5 centimeter, it will become 10 raised to power 10 centimeter square. Vice versa, if 1 meter square is equal to dash kilometer square, it will become 10 raised to power minus 6. And 1 centimeter square is equal to dash kilometer square, that will become 10 raised to power, perfect, 10 raised to power minus 10 kilometer square. I hope you are getting this. Is it simple? So in case if you have doubts or difficulties, put it in the comment box. You can like or thumbs up for these videos. In case if you have not subscribed this Easy ICSE channel, please do subscribe this channel so that you will come to know all that recent notifications. Okay, anyway, we'll go ahead. So these I have already explained you. 1 centimeter is equal to 10 raised to power minus 5 kilometers, or that 1 centimeter square is equal to 10 raised to power minus 10 kilometers square. There is one more third conversion which is very important. Let's see that. This is very important. 1 meter cube is equals to 1000 liter. I'll put the box for it. And there is a star. You can put these stars also. So what is this? 1 meter cube is equals to 1000 liter. See this meter cube going to liter. 1 meter cube is equals to 1000 liter. Put this in your notebook. 1 meter cube is equals to 1000 liters. So 1 meter cube is equals to 1000 liters. Can you see along with me? 1 meter cube is equals to 1000 liters. Okay, there is one last. 1 liter is equals to 1000 centimeter cube. 1 liter is equals to 1000 centimeter cube. Okay, so over here we are ready with our all basic components like concepts as well as the conversions. And now we are ready to solve some sums based on this size transformation. So are you all ready? Sure, we'll start. Okay, please open your textbook, sum number 13. Okay, in case if you have latest 10th standard textbook of ML Agarwal, open page number 351 and sum number 13 I am doing right now. Okay, so we are doing sum number 13 of chapter test. So let's read the question. A model of shape is made with a scale 1:250. So what is the scale is? K is equals to 1 upon 250. You can start writing simultaneously. So what is given thing? Always student write it down what is given. Sum writing given. K is equals to 1 upon 250. What's the next line? Calculate the length of the shape if the length of the model is 1.6 meter. Now there are two components. One is model and one is actual shape. So let's write it down. Model and actual shape. Okay. So, okay, this is correct answer. Some people might be confused. So length, if it is 1.6 meter, then actual is question mark. Let's read once again the question. The length of the shape you have to calculate. The length of the model is 1.6 meter. If the length of the model is 1.6 meter, actual length of the shape is question mark. I hope you understood how to make the table. Next, what is the next part of the question? So the next part of the question is, okay, let's read area of the deck of the shape. Since it's area, I have written over here area. A for area. Area of the shape. Area of the shape were to calculate, so I wrote area of the shape over here, actual shape over here. It's where to calculate in case the area of the deck of the model is 2.4 meters square. That's like the given thing. 2.4 meters square is the area of the model. So what is the actual area? And then one more thing is asked, the volume of the model. We have to calculate the volume of model. Go to calculate the volume of model in case the actual shape is 1 kilometer cube. If actual shape's volume is 1 kilometer cube. Volume of the model, if the volume of the shape is 1 kilometer cube. So these are the three basic questions, 1, 2 and 3. What we have to do. And now student, it's very simple. Actually this is 3 marker questions because there are 3 things has been asked over here, 1, 2 and 3. So even if you will get 1 correct, you are eligible to get 1 mark. If you get 2 right, you're going to get 2 marks. And if you get all 3, then you're going to get 3 marks. So our target is to get all 3 marks. Here, most important thing, like generally student write only number over here. So it is mandatory that you must write all the units, because if your units are correct, then only you will going to get that 1 full marks. Otherwise, again there might be reduction in the marks. So let's go ahead. So what we have to calculate actually the actual length of the shape. So which formula we are going to use? Refer your formula page. Which formula we are going to use? Length of actual shape in case if we calculate. So K is equal to length on map upon length actual. K is equal to length on map upon length actual. Or you might have written length on map is equal to K times length actual. Both are one and the same formula. So let's substitute the formulas. K. What is K? K is over here, it's written. K is 1 upon 250. So we're going to fill that 1 upon 250. Length on map is 1.6 meter and the length actual we have to calculate. So let's see. K is 1 upon 250. Length is 1.6 meter. Please note down. I have already written that unit and length actual we have to calculate. So let's say that is x. So how do we calculate this x? So x will go other side, 250 into 1.6. So that is 25 into 60, which is 400 meters. So this is our right answer, 1 mark. I hope you have understood till here. Okay, so what's the second part of the sum? The second part of the sum is we are going to calculate the area, actual area. So how are we going to do that? We're going to write k square is equal to area of the model upon area actual. We can write k square is equal to area of the model upon area actual. Please student keep writing simultaneously so that maximum number of the sums we'll be able to do in this particular session. So k square is equal to area of model upon area actual. And now see k square, what was k? 1 upon 250, 1 upon 250, isn't it? So k square would be 1 upon 250 into 1 upon 250. Many people they write over here k square, but they write 1 upon 250 only. So that goes actually wrong. So make sure that you've written 2 times. So what is the area of model? It is given over here, students. Look at this, 2.4 meters square, isn't it, students? So 2.4 meters square was the area of the model. So do substitute properly. 2.4 meters square is the area of the model. And what we have to calculate? Area actual. So area actual, again I have written x over here. So I'll just cancel it and I'll write y. So how are we going to calculate this y? Y will come over here, 250 into 250 will go in the other side in the numerator. So that y can be calculated as 2.4 into 250 into 250. That's meter square. Note down I have written the unit also. So 24 into 25, 600, 600 into 250, 150 and 4 zeros. That is 150 and 3 zeros. Sorry, 150 and 3 zeros meter square. So that is value of y. I hope you have understood. And what was this? Y was nothing but area of the actual shape or area of the deck of actual shape. So that is 150,000 meters square. I hope you have understood till here. And what is the last part of the sum? See student, what is the last part of the sum? Volume of model in case the volume of shape is 1 kilometer cube. So what formula we're going to write, students, over here? See, whenever we're going to calculate the volume, we write k cube. K cube is equals to volume of model upon volume of actual. K cube is equals to volume of model upon volume of actual. And now how are we going to calculate or how are we going to substitute this k cube? We will going to write this 1 upon 250 into 1 upon 250 into 1 upon 250 because it's k cube. We have written 1 upon 250 3 times. What is the volume of model? Which we have to calculate, and the volume actually is given as 1 kilometer cube. See student, there is something very interesting over here. It is 1 kilometer cube. Now how to convert that 1 kilometer cube? Or else the answer would be 1 upon 1 upon 1, 250 into 250 into 250. It will be huge number, isn't it? So what I can do, I can convert this 1 kilometer cube into meters, meters and meters. Like 1 kilometer can be written as 1000 meters, isn't it? So I'll write 1000 upon 250, 1000 upon 250, 1000 upon 250. So all those students who have just recently joined, just pay attention on the screen and simultaneously keep writing. See, look at this. So I wrote 1 kilometer cube can be written as 1000 meter, 1000 meter, 1000 meter, isn't it? See, 1 kilometer cube can be written as 1 kilometer, 1 kilometer, 1 kilometer, and that 1 kilometer I wrote 1000 meters upon 250, 1000 meters upon 250, and 1000 meters upon 250. 250 fours are 250 fours are 250 fours are. So 4 into 4 into 4, that's 64 meters cube. So volume of model is equals to 64 meter cube. So here is the student, our final answer is ready. And I hope student By this way, we've understood all the concepts of the size transformation as well as we have completed one sum. In case if you have doubts, you can ask your doubts in the comment box. By now, in case you have not subscribed this channel, please do subscribe this channel and watch this video till the end so that you'll understand all the concepts. So let's start doing the next sum. I hope you completed all the sum, entire sum writing in your notebook. So let's go to the next sum. This is sum number 17. So let's come back to sum number 17. Please open the page number 345, page number 345. Sum number 17. So, what exactly the sum is? Let's read it. On a map drawn to the scale 1:250,000. So, I have written K. 1:250,000. A triangular plot of a land has following measurements. So there is a triangular plot, so I've drawn the triangle over here. It's given that AB is equal to 3 centimeter, BC is equal to 4 centimeter, and angle ABC is 90 degree. So in triangle ABC, angle B is 90 degree, AB is 3 centimeter, and BC is 4 centimeter. Next, calculate the actual length of AB in kilometers. See, we have to calculate these following things. So it's given that actual length of AB in kilometers square. So that is the first question. And what is the second part of the question? The area of the plot in square kilometers. Area of the plot in square kilometers. So I must know what is the area of on the map or else on the model. So this is basically map. So I cancel this and I'll write it down with the map. So area on map we can calculate. Area on the map would be half base into height. Half base into height, isn't it? And we know the base is 4 and the height is 3. So half into 3 into 4, which is 6 centimeters square, which I wrote over here 6 centimeters square. And we have to calculate these two things. Isn't it very, very simple? So students, let's start doing this sum. Do it along with me. Since we have to calculate actual length, so we will use the formula of K. K is equals to length on map upon length actual. Now we have to substitute this K. What is this K is? Look at this, 1/250,000. So 1/250,000, which is equals to length on map is, look at this, length of AB on map is 3 centimeter. So that is 3 upon length actual. Now student, once again, I have forgotten over here unit. So what was the unit given? Unit given was centimeter. Unit given over here was centimeter and expected unit is in kilometer. So see, this is what student I was talking previously. So whenever you are working, see to it that or mind all the units very carefully, because in the examinations you must write accurate answers, and for accuracy there are a lot of marks. So length actual would be 3 into 25, that's 75, and then there will be 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros, and that too the unit will be in centimeters. But if we want it in kilometers, if you have to convert this, what I'll do, I'll shift this dot 1, 2, 3, 4, 5 places behind, isn't it? Okay. 1 centimeter is equal to 10 raised to power minus 5 kilometers. So whenever it is 10 raised to power minus 5, we will go back or we will go to left. So we will come back to left. So that is 7.5 kilometers. I hope you have understood this. In case not, put the doubt in the comment box. And now what is the next thing is, we have to calculate the area actual. And how do we calculate the area actual? It's very simple. Again, we will going to use that conversions. K square is equals to area on map upon area actual. And what is that area? So like 1 upon 250,000 into 1 upon 250,000, which equals to area on map is, we will calculate it 6 centimeters square. So that is 6 centimeters square upon area actual. Isn't it very, very simple? So now you can calculate this. It's very simple. So area actual is equals to 6 into 25 into 25, 625 into 1, 2, 3, 4 and 10 raised to power 8 centimeters square. So students understand, we want it in kilometers square. So we want 2 more zeros, so we will go 6 into 6.25 kilometer square, because we want 10 raised to power 10. So I've shifted 2 dots behind, so it will become 6.25. And now is 6 into 6.25, 6 into 5, 25. Okay, 6 into 25, or 6 5 is 30, 3 carry, 6 2 is 12, 12 plus 3 15, 1 carry, 6 6 is 36, plus 1, 37.5 kilometer square. I hope you have understood, student. And over here we finished our second sum. So this is what the answer is. So you can plug the answers in your box. So this is 7.5 kilometers. Okay, sorry. So this is 7.5 kilometers and this is 37.5 kilometers square. Isn't this topic is very, very simple, students? So we make learning easy at Easy Learning Center. So we make learning easy at Easy Learning Center. So I hope you have understood this entire topic, students, all of you, isn't it? So let's do few more sums based on this. So we will do now sum number 20. Oh, we'll do sum number 19. I have already structured. So let's do sum number 19. Sum number 1919 on page number 341. Page number 345. And we'll do sum number 19. So the model of a building is constructed with the scale factor 1:30. So always students remember that 1:30 is nothing but K, which is scale factor 1:30. So 1 indicate the length on the map and this 30 indicate the length on the actual. So we'll write it down all the data over here given one by one. One second, I'll just clear this data. Okay, so we had been given something like this. If the height of the model is 80 centimeters, so over here, instead of length, they have given height. So there can be length, breadth, height, or the diagonal. So these all are one-dimensional things. So height is given as 80 centimeter. Find the actual height of the building. So we have to calculate what is the actual height of the building, and that is our part one answer. And next, if the actual volume of the tank of the top of the building is 27 meter cube, the actual volume is 27 meter cube, find the volume of the tank on the top of the model. So of the models, it is question mark. Okay, they have not expected any unit, so you can calculate in any unit. Let's see how exactly this sum can be worked out. Yeah, there are only two parts. So, how exactly are we going to do this sum? Since the height of the model is given, and we're going to calculate the actual length, we will use formula. It's directly volume. I have come up with. So I'll show you the first part of the sum. What the first part of the sum is? K is equals to height of model upon height actual, isn't it? K is equals to, write the correct formula, K is equal to height of model upon height actual. What is K is given as? 1 upon 30, very good. What is the height of the model is given as? See, refer in our table, it is given as 80 centimeter. So I'll write it down over here, 80. See that I have written in unit upon height actual, which were to calculate. Isn't it very simple? It's really simple. So how am I going to do that? It just do cross multiplication. So height actual is equals to 30 into, we just do cross multiplication, 80 centimeters, which is 8 is a 2400 centimeter, which can be converted as 24 meters, isn't it? Because 1 meter is equals to 100 centimeters. So I just reduce that to zeros and I convert it into meters. So in case if someone has got us 2400 centimeters or 24 meter, both answers are right. I hope you have understood till here. So let's continue ahead. What's the second part of the sum? What is the volume of model if the actual volume is 27 meter cube of the tank? So how are we going to do that? K cube is equals to volume of model upon volume actual. K cube is equals to volume of model upon volume actual. So what is K cube? 1 upon 30, 1 upon 30, 1 upon 30. Volume of model, which we have to find, and the volume actually is equals to 27. Now we have noticed this I have taken 27 to other side, 27 into 1 into 1 upon 30 into 30 into 30. So there are 1 upon 1000 meter cube. Now 1 meter cube can be written as 1000 liter and upon 1000 as it is. I hope most of the students must have not understood this. 1 meter cube, look at this, 1 meter cube, because I got cancelled 3 into 3 into 3, that's 27. So 1 meter cube upon 1000 we got 1, 2, 3 zeros, isn't it? Now 1 meter cube I have written that as 1000 liter. 1 meter cube is equals to, why? Because 1 meter cube is equals to 1000 liters, isn't it? So 1000 upon 1000, which would be nothing but 1 liter. So the volume of the tank of the model is just 1 liter, and that's your final answer. I hope you understood till here. So that's 1 liter. So we'll fill it 24 meters. So this answer is 24 meters, and this answer is 1 meter. I hope you have understood till here, and in case not, please ask your doubts in the comment box. Yeah, someone is asking the doubt as, can we keep the answer as 1 meter cube upon 1000 liter? You can leave your answer as 1 meter cube upon 1000, but we know the conversions of 1 meter cube, which is 1000 liters, so it is always preferred like this way. I hope that's fine with you all. So here we will stop with these our sessions because now I have my regular class. So what we will do, you can do the remaining sums as a homework 17, 18, 19, 20, and then in the next session we'll join with similarity, actual similarity chapter. And this was like very small topic of the similarity chapter because over here everything is in the chapter similarity, the size transformation and the similarity and the area theorem. So in the next session we'll look into what exactly is area theorem and how to find the areas of the triangles. So keep watching this channel. Channel name is Easy ICSE for such kind of videos, and let's see in the next video what is area theorem. So thank you for watching this channel.